In this video, we're going to look at investigating average rate of change. This particular lesson happens to be in the 10th unit of pre-calculus. So at the end of the year, we're now into the fourth 9 weeks and nearing the end. And so this particular lesson on investigating average rate of change is actually the second one in the unit. And you can see that the unit starts off with some discussion of average rate of change versus instantaneous rate of change. And so they'll already have sort of looked at that vocabulary, and this is just extending those ideas. And then moving on to definitions of the derivative and mechanics of derivatives as you move on through the end of that unit. Okay, so in the scope and sequence for this unit, this is the scope and sequence for lesson 2, and you can see again we've allotted 2 days, and these particular lessons we are planning to address the course of study numbers 24 and 25. In particular, we're looking at estimating and interpreting the average rate of change, while of course looking at features of a graph. And we'll be looking mainly at polynomial functions here, but other aspects of the lesson through this unit, we'll talk about some of those other functions. There's several things here that you want to address with your students, and so we're going to just kind of look at some of those things as we go through. You'll notice on the scope and sequence, in addition to some facts about how you might want to consider moving through the lesson, there are also calculator tips thrown in there to help you, and we're going to look over some of those as we go through. So on this particular lesson, we're going to look at problem number 1 for investigating average rate of change. So for y equals f of x on the interval from a to b, the average rate of change is delta y over delta x, or f of b minus f of a over b minus a. So this quantity and this idea should not be foreign to them. That should be quite familiar. And of course, they've looked at it for a couple of days, but they've also done that in Algebra 1 and again in Algebra 2. So this is certainly not a new concept. The fact that this is the slope of the secant line would have been discussed in the earlier 2 days of this unit. But again, it's an important thing to consider that the secant doesn't necessarily have to be on a circle. I think kids come into pre-cal and calculus thinking that, but that's an important distinction to make. We're just looking at the slope calculated between 2 points of change, as opposed to the slope being just looked at 1 point. So we're going to look at, to start off with, the function 3x plus 1, and we basically want to calculate the average rate of change on all these different intervals. Okay, and you can do that, of course, by hand. You can have your students plug that in. It's not that hard of arithmetic. They can certainly do it. It's not that complicated. But remember, the focus of this lesson and this activity is really not about the arithmetic. That would have been something they would have focused on in Algebra 1 or in pre-algebra. Certainly in this class, we're hoping to move them on further into some understandings of what these things mean. So rather than spend all of the time that it would take to do all that work by hand, we're going to use our calculator, and I want to show you a couple of tricks about how to do that. So I'm going to remember that my equation is 3x plus 1. I'm going to go to my calculator and I'm going to go to my y equals, and I'm going to put in 3x plus 1. Which is the equation that we were just looking at. Okay, so now what I'm going to do is go back to my main screen, all right, and I'm going to get a fraction, all right, and so I put that f of x into the y1, so the name of that function is y1 on this calculator in my student notes, in my work that I'm doing. The name of it is f, but on my calculator, my f of x is going to be my y1. So I'm going to go back to my calculator, and I'm going to use the my shortcut keys, so the alpha and trace, and pull up the Y1 option. And I want to evaluate that at, and I have forgotten that order pairs, that interval. So let's go back. And that's the interval from -5 to -1. Okay. So I basically want to go f of -1 minus f of -5 over -1 minus a -5, right? But on my calculator, those f's are going to be y1s. Okay, so let's go back and put that in. So f of a -1 and then minus. Again, I need that trace, alpha trace, and that's at a -5. Okay, and then in the bottom, -1 minus a -5. And I'm going to hit enter. And it should give me a 3. And maybe you want to pause at that point and have some discussion, or go back and look at those things. And there's actually 5 different intervals for you to calculate. So we can go ahead and calculate the interval for 2, 8. So let's do that. And I'm going to show you a little trick for that as well. We can just arrow up with our calculator, hit enter, and rather than having to type all of the work in again, which in this case, oh goodness, let's go back, second mode, there we go. All right, so I'm just going to, I keep hitting the down arrow. Let's try that again. Okay, so that is going to be a 2, and then keep going over, and this one is an 8. Remember, we're on the interval 2 to 8, and then the bottom is going to be 8 minus 2. And if I hit enter, I get a 3. So just a little trick to help your students get more familiar with their calculator. What you may want to do in your classroom is have one group do this one and one group do that one, and so on and so forth, and then popcorn around the room, have them call out their answers, and they should all get 3, of course, and so then we know that the instantaneous rate of change is just 3. Number 2 is a very, very similar problem, and will take you very little time to do, especially if you, again, kind of assign those out to groups, have them throw out the answer. And then you want to spend a few minutes kind of talking about number 3 and thinking about what it might mean. Just as a note, when you get to problem number 4, it's going to be kind of important on that problem that you actually have them make sure that they plot points at these particular places, and that's going to be important in order to answer some of the questions. But there's several questions in here. Just again, the first 3 problems in this lesson are all about lines. 4, 5, and 6 are quadratic functions, and then number 7, which is where we're going to go now, is sort of an application and sort of extending our thoughts on. And so here we have a car company that's testing the speed and acceleration of one of its new sports cars, and the table here shows the distances the car travels when it accelerates from a standstill. So we're going to use a graphing calculator here. And the very first question they're asked is to explain why the data is not linear. And of course, you're hoping to hear from them that it's because the average rate of change isn't constant. And I often will abbreviate that AROC, but the average rate of change is not constant. And so that's what you hope to hear. Of course, you want to, pull some discussion out from your students and get that from them. And then, again, some discussion about part B would be good. And hopefully, eventually, they'll see that that is simply just the average speed of this car in meters per second. Actually, probably should say velocity there, because and then we're going to move on and look at part C. So in part C, it says to determine the quadratic regression function R of t for the data. So they're telling me, okay, you recognized up here that this is not linear, and I'm going to tell you that it's actually quadratic. And I want you to get the formula for that. So that's what we're going to do. We're going to look at how to do that on the calculator. And so in order to do that, I'm going to need to have that data So let's see. There's that data right there. Okay, so we're going to go to back to our calculator, and we're going to go to the stat button, and we're going to hit enter, and we're going to enter the time data in line 1 in L1, column 1, and the distance data in column 2. So I'm going to have a 0, and then a 10, and then a 14. Okay, and then an 18, and then a 20. Okay, and then in L2, I'm going to have a 0, and a 225, a 375, 550, and 650. So I have my data all entered into my calculator, and I am ready to make the calculation. Okay, so when I go to make that calculation, I'm just going to hit stat again, and when I hit stat the next time, rather than edit this time, I'm going to go over to calculate, and I want to run some regression on this thing. So I know it's not a line, so I'm not going to do 4, sorry, not going to do 4. I'm actually going to choose the quad reg, which is number 5. So I'm going to hit 5, and you'll see that it comes up and says, okay, is your data in list 1 and list 2? And yes, and we don't have a frequency list. And right here where it says store regression equation, that's what that stands for, you can actually have this stored in your Y1 of your calculator, and or in your function editor of your calculator. We actually probably are using Y1 right now, so if we want to store it in another place, we can do that. So that's what I'm going to do, and I'm going to do that by hitting alpha and trace and tell it to store it in Y2. Okay, you can store it wherever, and then I'm going to go down and have it calculate the information. And you can see that is my regression equation. And if I go over to my function editor, you can see that it has put that information in there. Now I saved that Y1 even though I don't really need it, so I'm going to delete that out actually, and I'm going to graph this thing. Now if you go back to our data and remember, we really don't have any negative data values, so I'm going to go to my window and just put a 0, and my highest y value was like 20, I think. And then for my y, I'm going to put a 0, but my highest y value was actually a good bit higher than that. I think it was like 700 or something. So that's what I'm going to put in for my value. And then I'm going to hit graph, and you can see there's the curve. Okay. If we go to second and stat plot, and we turn on the stat plot, and we tell it we want a scatter plot and L1 and L2, it will actually graph that data for us, and we can see there's that regression data. So it's really good quadratic regression line, or not line, but curve that we have there given. If we go back to the student pages, you could have them write that regression formula in there. Of course, you want them to round, and I would always encourage my students, when you round, to use 3 decimal places. I don't know, you may be aware that that's required on the AP exam, so it would definitely require at least 3 decimal places. And then the next several problems are going to be done using this quadratic regression. And of course, you could assign those out to your students to think about as they move through. I hope that this lesson is one that you enjoy, and thank you.